Hey guys, Prof. Essie here. In this video we're going to talk about calculating surface area. As I mentioned, it's often, in the previous video I mentioned that it's often taught using nets. Really I think the key idea is to, first of all, surface area. What is it? It's really just the area of all the surfaces, area of all the faces, unless it's a cylinder. Then they aren't faces, but you get the idea. So area of the outside, sometimes it's called. But I would encourage you to just really ask your future students about the faces of the polyhedra. How many faces are there? What are the shapes? What are the sizes? They need to be able what we call decompose. Decompose is just a fancy word for breakdown. So they need to be able to break down this picture into its pieces or its parts. And you hear this word throughout mathematics, decomposing fractions and other things. And if you have a set of 3D objects, that helps them a ton as well. So let's decompose this into smaller parts. What do you see? How many faces does this have? Well, hopefully, first of all, you're seeing the triangles here and realizing it's a triangular prism. And hopefully you're seeing 2 triangles and 3 rectangles. There's a rectangle in the back here. There's a rectangle on the front left and a rectangle on the front right. So 2 strategies for solving this, and maybe I'll try to do both. One is to draw a net of this object. The other is just to break it down by parts. So I'm going to do it by parts first. So we have a top part, which that top part is going to end up being a triangle shape that's 3 by 3. We have a bottom, which is that same triangle part here. I think it's kind of funny I'm pasting such a bad picture of a triangle. We then have the back, which is a rectangle. Go like that. What do we know about that back? Its height is 6 and its length is 4.24. And then we have the front left and the front right, which are also rectangles. They're going to be a little bit skinnier rectangles. And what do we know about these rectangles? We know that these rectangles are also 6 millimeters high, but they're 3 millimeters wide. Now, to find the surface area, you just have to find the area of each piece. So hopefully you're comfortable finding these areas. For a triangle, we're going to take half of the base of the triangle times the height. So 3 times 3 is 9, divided by 2 is 9 halves. This is 9 halves. 6 times 4.24 is 25.44. 6 times 3 is 18. 6 times 3 is 18. So the total surface area then is just adding those up. So 9 halves plus 9 halves plus 25.44 plus 18 and 18 gives us 70.44. And what's our label on that? Hopefully you're thinking each of these was measured in terms of area. So if you could picture this as being 3 by 6, those are all square millimeters. And that's true for all of these. So my final answer is in square millimeters. So one method is just to decompose it like I have here. The other, which is what I think is typically shown, is trying to draw a net of this. But I think this is challenging for students. The net is basically going to be, because I've thought about this and done this a fair amount, it's just going to be a big rectangle with a 3 meter by 3 meter on either end and a 4.24 millimeter in the middle, a 6 meter on the side, and then 2 triangles here. That's 3 by 3, and sorry, that's 3 by 3. Hopefully you can see how that connects. If not, look at the previous video. Here's the back. Sorry. Here's the back. Here's the front right side, front left side. If you can imagine connecting those. If this side connects with this side, it would fold up. And then the triangles fold up. From here, it's really the same process that I used over here. We know this is 6, so this is 3 by 6. This is 3 by 6. This is a triangle. You do have to kind of rotate it in your mind and realize, hey, this is a base and this is a height. So then the area of this triangle ends up being 9/2 or 4.5, 4.5, and this ends up being 4.24 here times 6 here. I hope these A's aren't confusing. And so then we get the final, or the area here of 25.44. And then we just have to add the area of each piece together. I'm not going to go all the way through this one. I just want you to be able to decompose it. Let me go back. Quick review. Either method, you end up with 5 shapes, and you have to find the area of them. There are some shortcuts. You could take this one times 2, and this one times 2, and then leave this one and this one off. That would work fine. Sometimes shortcuts are helpful, but I find for some students just doing it longhand first is helpful, and then doing the shortcuts once they're comfortable with them. All right, let's take a look at this one. Actually, I'd encourage you pause it and find the surface area yourself first, and then watch the rest of the video. I'm really picturing a square on the bottom that's 3 by 3, and then I'm seeing 4 of these triangles. And you'll notice there's 2 different heights here. There's the slanted height, which is the vertical, or there's a slanted height, and there's a vertical height. So this distance is actually longer than going straight down to the bottom. Hopefully that makes sense to you. When you think about this triangle here, the question is, what is the height of this triangle in the picture? Is it 11 or is it 11.1? Hopefully you see it's 11.1. And this is 3. So from here, we can just find the area of each. 3 by 3 is 9. The area of one triangle is half times 3 times 11.1. That's going to give me 33.3 divided by 2. 16.65, and that's for one triangle. So the total surface area is 9 plus we need 4 of the 16.65, and that's going to give us 75.6. And the label on this, well, hopefully you're seeing area and thinking we're counting squares, so this is going to be square yards. So our final answer is 75.6. If you did the net, the easiest way is to, I think, to start with the base and then realize off of the base you're going to have 4 triangles. But again, I just think it's a little more challenging for students. They still have to decompose it. They almost have to decompose it first and then think about how they all fit together. Where with this strategy here, they just have to decompose it and they don't have to fit together. But I will leave that up to you to figure out how to teach when you're in that spot. So, big takeaway, surface area is finding all of the areas of the surface.